Okay, it's 11 a.m. Eastern, so let's go ahead and get started. Good morning, good afternoon, and good evening to all our customers joining us from across the globe. Hello, everyone. My name is Lokesh Charara, and I'm the Senior Manager for the Arista Technical Services team. On behalf of the entire team, I extend a warm welcome to each and every one of you to this remarkable webinar series graciously hosted by the Arista Technical Services team. For our customers who are joining us for the very first time or maybe joining us after a break, I will quickly cover a few details about this initiative. Rich, can we move on to the next slide, please? Our aim with these webinar sessions is to work on sharing the knowledge that we cultivate here in TAC World with our customers, and also at the same time cover topics in depth which are most useful and applicable to all our customers. We kicked this effort off in 2022 to cover topics like switch health checks, upgrades, and the maintenance planning. And in 2023, we shifted our focus a bit onto more technical topics. And throughout this year, we have covered topics like Layer 2 and Layer 3 debugging, VXLAN debugging, and in the Q3, basically, we are covering the EVPN debugging. So today's session is basically our third session in the series of the EVPN troubleshooting, and that makes it 9th overall this year. Recording of all our previous sessions, including the presentation material and question answers, which are covered as part of the previous sessions, are available on our Arista community page if you would like to review it. Coming to today's session, we actually are going to do a deep dive into the EVPN multi-homing setup and cover some use cases that we see in our TAC interactions and common problems that we come across with our customers in our TAC cases. We will go over the debugging steps, which can be applied to troubleshoot these problems, and also at the same time, EOS CLI tools that will come handy in such situations. So for today's session, we have our technical lead and EVPN subject matter expert, Rich Johnson, who will be walking us through these debug scenarios. Rich will take us through some lab scenarios that we have encountered in our TAC interactions. And for everyone's reference, we have prepared a lab topology diagram, and we already sent it out earlier this week to our registered customers. Rich will be highlighting this topology in between the debug scenarios, but again, it'll be a good idea to take a snapshot of this topology and keep it up on your screen for reference. We have a PDF download link available in our Q&A section, which our panelists are putting right now. So please download it and keep it handy during the course of the presentation. Along with Rich, we also have our technical leads as part of the panel who can help answer any questions that you may have during the presentation. So you can use our Q&A manager to ask our panelists any questions at any point during the course of this presentation. Rich, can we move on to the next slide, please? So a brief update about the upcoming 2024 series. After today's session, we'll basically conclude our 2023 series and we'll resume again in 2024 with some more interesting topics. Our next session is going to be on 31st January on troubleshooting issues related to the network latency and traffic blackholing and other related issues like packet drops in the network. So we'll be sending regular communication as we resume back after the winter break. But before we dive into the troubleshooting scenarios, I briefly would like to introduce our new product offering, that is TAC Custom Training. Based on the valued feedback that we've been receiving from a lot of you and just a wider interest in the personalized training, we have kickstarted this effort, which is essentially a fully customized training session led by our TAC experts. What we do in these sessions essentially customize the content based on the feature set, platform, design that you have in your network environment. We also include a comprehensive analysis of the recent TAC cases that you have opened with us as part of these sessions to provide you a complete view of your network and the problems that you've been experiencing in your network, along with the key recommendation from our experts. So these recommendations basically help overcoming these problems in order to avoid the outages. These sessions also they are delivered in form of a debugging session to ensure readiness of your network operation teams to handle any such challenges. Since we have started this offering, we have delivered many such sessions to our cloud titans and enterprise customers, and we continue to receive great feedback on the quality as well as the content. So this is a paid offering, and if you are interested in scoping a session with us or just interested in learning more about this offering, please reach out to us on the alias mentioned here, which is tag-custom-training@arista.com. Also, if you are interested in any general technology training or ACE certifications, please contact our Arista training team at training@arista.com. At this point, without taking any further time, I will hand it off to Rich to take you through the CLI part. Rich, take it away.
Thank you, Loki. Good morning, good afternoon, good evening, everyone. Thank you for attending. Today, we'll be discussing troubleshooting traffic flows in an EVPN VXLAN environment. My name is Rich Johnson. I'm a TSE here with the Arista TAC. Okay, so today's scope will discuss Ethernet segments, all active multi-homing route types, the advantages over MLAG. We'll discuss type 5 IP prefix routes, and troubleshooting EVPN VXLAN issues in a multi-homing environment. So some of the terminologies that we'll use will be CE for customer edge, PE for provider edge, and ES for Ethernet segment. One of the clear advantages that multi-homing has over a provider solution like MLAG is there's no dedicated peer link required. Also, with issues with like MLAG, we only support 2 peers. Most solutions like MLAG support 2 peerings, whereas EOS supports up to 16. And you can see here that the CE device is connected to the provider edge devices via a port channel. This is known as an Ethernet segment. Each Ethernet segment has its own identifier, or ESI, which is a 10-byte value that uniquely identifies the Ethernet segment. And you can see the identifier here, ending in 0111. Okay, there are 2 new route types with multi-homing. Type 1 auto discovery, or AD routes, and type 4 Ethernet segment routes, or ES. So type 1 auto discovery routes are used by remote peers that are not participating in the Ethernet segment. And just like type 2s, there's actually 2 types of type 1 routes. So first, there's the per EVI route here. These announce the reachability of multi-home Ethernet segments, and it helps with fast convergence or mass withdrawal of MAC addresses when there's an Ethernet segment link failure. Also, there's the per Ethernet segment routes. These announce reachability to a given EVPN instance for the Ethernet segment, and they're used for aliasing. Okay, so if we take a look at the MAC IP route here for host 1, we can see it's a MAC IP, and you can see that there's a non-zero Ethernet segment identifier here, and it ends in 0111. So if we take a look at the type 1 routes that match the Ethernet segment ending in 0111 here, we can see that VTEPs 1 and 2 are attached to the Ethernet segment. And we can see that they each advertise a AD per EVI route and an AD per Ethernet segment route. So let's discuss load balancing across multi-home VTEPs, or PEs. So in a case where a CE device is multi-home to multiple PEs using a port channel, it's possible that only a single PE learns the MAC address of the CE, right? So the traffic may only hash to one PE device. So that PE device will advertise a MAC IP route to remote VTEPs. And so they will only receive one MAC IP from one PE, even though there are multiple PEs attached to the segment. So to address this issue, EVPN introduced the concept of aliasing. So if we look here, we have host A with IP A and MAC address A. It is sent an ICMP packet that hashes to leaf 1 here. So Leaf 1 advertises a type 2 MAC IP route for MAC A, and it also includes the ESI1, and itself is the next hop with IP1. It also advertises an AD per EVI route for ESI1 with a VLAN 111 route target and itself with IP1. Leaf 2 belonging to ESI1 also advertises a per EVI route with itself as IP2 and ESI1 and the VLAN 111 route target. So Leaf 3 receives all three of these routes. And as such, it programs an overlay ECMP for the MAC in question. You can see MAC A now has a next hop of IP1 and IP2, and IP2 aliasing. So let's look at that from Leaf 3's perspective. It has received 2 AD per EVI routes for a segment here ending in 0910 from VTEPs 1 and 2. And it's also received a MAC IP route for a host with the MAC ending in 8910. That's on the Ethernet segment ending in 0910. As such, it's programmed a layer 2 ECMP here for the MAC ending in 8910 via Leafs 1 and 2. So let's talk about type 4 Ethernet segment routes. So these routes are used to discover peers that are attached to the same Ethernet segment. They're also used to elect the designated forwarder, the role of which is to forward bum traffic received via the overlay onto the segment. So here, with the command show BGP EVPN instance, we can see that this is the instance for VLAN 111. We see the ESI here ending in 0111. There's an Ethernet segment import route target. And the designated forwarder here is 4.4.4.4. So if we take a look, both PEs 1 and 2 have received encapsulated bum traffic from the overlay. However, PE2 being elected as a designated forwarder here is the only device that will forward that traffic onto the segment. This helps with duplication. So let's take a look at problem statement 1, duplicate traffic. So the scope here is this is an active-active multi-homing model with layer 2 EVPN. It's a day 1 issue. The issue is observed when pinging host 2. It's not observed when pinging any other host in the fabric, and it's consistently reproducible. So the sample flows are there are duplicates from any host pinging host 2, which is 10.10.111.222. And the ping across all other hosts is considered working. There's no duplicates. So when host 1 pings host 2, it sees duplicates. But when host 1 pings any other hosts, such as 3, 4, and 5, there are no duplicates. So let's take a look at that on the CLI. So our problem statement here is that when pinging host 2 from host 1, we observe duplicate packets. So let's go over to host 1 and see if we can confirm that's the case. Okay, so we do see duplicate packets here. How about when we ping other hosts in the fabric? Okay, so when we ping other hosts, we do not see the duplicates. All right, so let's run the capture on host 1 while we're pinging. Okay, so if you take a look here, we see discrete sequence numbers. So it doesn't appear that host 1 is sending duplicate echo requests. So if we go over to Leafs 1 and 2, and run a capture here. First, we can see that it appears that all of the traffic is hashing to Leaf 1. Okay. So if we take a look at Leaf 1 again, we see discrete sequence numbers ingressing. So we can confirm that host 1 is not sending duplicate requests. Okay. Let's run a capture on host 2. Now on host 2, we can confirm that we see duplicate requests here. We can see 2 ICMP echo requests, both with sequence number 65. So based on this, it appears to indicate that the network is responsible for the duplication. And since ICMP is not stateful, host 2 will simply reply to each of these requests. This explains the duplicate replies we see when we ping host 2. Okay, so let's go over to leaf 1 and 2. And let's take a look at the MAC address table for VLAN 111 here. Okay, so we know that host 2's MAC ends in alpha 7, Charlie 7. You can see it in the echo request there. So we do not see this MAC address being learned on host 1 or host 2. Okay, so let's take a look at EVPN here, specifically for MAC IP routes. And we do not have a MAC IP route on leaf 1 or leaf 2 for host 2's MAC. So with EVPN, remote MAC learning is handled solely by the receipt of type 2 MAC address routes, MAC IP routes, sorry. So if you look at show int VXLAN 1, you see remote MAC learning via EVPN. And on leaf 2, you see the same thing. This confirms that we only learn remote MACs via type 2 routes. Okay. So leaf 1 and 2, if they receive traffic destined for host 2, having not learned host 2's MAC address, they'll flood to all the ports in VLAN 111. So let's take a look at VLAN 111, and we can see that port channel 111, which is the ingressing interface, is a member, as is VXLAN 1. So let's take a look at the flood list here. So show VXLAN flood VTEP. And we can see leafs 2 through 6. And leafs 3 through 6 and 1 here on leaf 2. Okay. So this is the flood list. And if you recall, these are built off of type 3 routes. So we can see we've received type 3s from all of the VTEPs in the fabric. Okay, so we have a flood list, and leaf 1, having received these echo requests, will flood them to all the VTEPs in the flood list. So if we run a capture, and we'll use a UDP offset here that matches on 11.4, which is the location of the VNI, and we're matching on VNI 10111, which is VLAN 111's. And let's take a look here. So we do see VXLAN encapsulated packets from leaf 1 to 3, and the inner packet is an ICMP request from host 1 to host 2. Okay. So let's take a look. Let's run this same capture on leaf 4. All right, we see the same thing. We see leaf 1 to 4 VXLAN encapsulated packets with an inner packet that is the host 1 to host 2 ICMP echo request. Okay, so this is expected. The MAC address is not known on the source VTEPs, and they're flooding towards the fabric. So leaf 3 and 4, where host 2 should reside, they're both receiving a copy of the traffic. Okay, so if we look at show MAC address here on leaf 4 does not know where host 2's MAC is. And if we look at show BGP EVPN instance, we can see that leaf 4 is a designated forwarder. So this is the instance for VLAN 111, and there's a local segment with an ESI ending in 0111, and this is for port channel 111, where host 2 should reside. And we can see that again, for that segment, leaf 4 is a designated forwarder. And if you recall, it's the role of the designated forwarder to forward ingressing VXLAN encapsulated bump traffic onto the segment after decapping. Okay, so if leaf 4 is the designated forwarder, then how do we explain the dupes here? We expect leaf 4 to forward a copy out onto the segment. And we can see that is the case. But does leaf 3 also send them? And we can see that that is indeed the case. So why are leaf 3 and 4 both sending them? So we know that leaf 4 is the designated forwarder. But if we take a look at the MAC address table here, on port channel 111, we see that host 2's MAC is actually learned by leaf 3. So since the MAC is learned, then leaf 3 is simply forwarding this traffic as known unicast. So the MAC is not learned on leaf 4, and it's the designated forwarder. It forwards the traffic onto the segment. This is expected. But since leaf 3 has learned the MAC, it's forwarding a copy of this traffic onto the segment. This is also expected. But if you also recall, leafs 1 and 2 have not received type 2s for host 2's MAC in EVPN. And we expect locally learned MAC addresses in VLAN 111 to be advertised as type 2 routes into EVPN. So leaf 3 is definitely receiving traffic from host 2, and it's learned its MAC address locally, but it doesn't appear that other VTEPs have learned it. So let's see if leaf 3 is actually advertising this MAC address. So let's see. It does not appear that that's the case. We do not see the MAC being advertised by leaf 3, even though it's learned locally. So sometimes it's good to get a sanity check, and let's just do that. So if we look at show BGP EVPN sanity, we can see that there's a warning for the layer 2 category. Let's add the detail keyword to increase the verbosity here. And if we do so, that same layer 2 where we see the warning, the check is for MAC VRF redistribute. So the message here indicates that the MAC VRF for VLAN 111 should enable redistribute learned or redistribute static. And if you remember, redistribute learned under the MAC VRF is the mechanism that takes locally learned MAC addresses and injects them into BGP for the VLAN. So if we run show run section router BGP here and take a look at the MAC VRF, we can see that redistribute learn is indeed missing. So let's correct this. Now, let's see if the MAC is being advertised. And we can indeed see that is the case. So now leaf 3 is advertising the MAC address. Now let's see, do other VTEPs receive it? So look at that. Leaf 4 has now learned the MAC address for host 2 as well, as has leaf 1 and leaf 2. So let's go back over to our hosts, and we can see already that it appears the duplicate packets are gone. Okay, so let's look at the summary here. So we confirmed duplicate pings when pinging host 2. No duplicates were observed when pinging other hosts. We focused on traffic flow between host 1 and host 2, and based on the MAC address table entries, it was confirmed that remote VTEPs were not learning the MAC address for host 2. Leaf 3 learns the MAC address for host 2, but is not advertising a type 2. Traffic from remote VTEPs destined to host 2 is flooded. So when host 1 would send a packet, it would be flooded to all the VTEPs in the flood list. It would arrive at 3 and 4. because leaf 3 learned the MAC address, it forwarded a copy of the echo request onto the segment. Leaf 4, not knowing where the MAC was, but it was the designated forwarder for the segment, so it forwarded a copy. That resulted in 2 copies arriving at host 2 and host 2 replying to 2 copies, hence the duplicates. We've referenced some commands used here for your reference. Okay, let's take a look at EVPN type 5 IP prefix routes. So here, leaf 1 is advertising the 10.10.10.0/24 type 5 IP prefix route with a layer 3 VNI of 50001. And if you look at the VXLAN interface configuration, we can see that VRF-A is mapped to the 50001 VNI. And if we look at the type 5 here in show BGP route type IP prefix, we can see the layer 3 VNI is indeed attached. So let's talk about problem statement 2. Here, there's a connectivity issue to a file server. The file server IP is 11.11.11.111. This is an active-active multi-homing with symmetric IRB, and traffic in VLANs 111 through 113 are impacted. Some of the sample flows are leaf 1 to the file server, host 1 and host 2 to the file server. And here you can see with our sample test that there are ping failures. So let's take a look at the CLI. In this scenario, our problem statement is that various hosts in the fabric cannot access the file server, which has an IP address of 11.11.11.111. So let's jump over to the hosts here and run a few ping tests here. And we can confirm that neither of these 3 hosts are able to reach the file server. So the customer indicates that this file server should be reachable through the border leaf. So let's take another look at the border leaf and see if it has a route to the file server. It does not appear that we have a route, and there's no default route. Let's see. There is, however, the prod VRF, which ET7 is a member of. And that is our ISP connection. And we're also peering BGP here with the ISP and the prod VRF. Okay. So let's see if we have a route in the VRF. And we do. So we can see that based on the next hop being a VTEP, there being a VNI included, and a router MAC extended community, that this is a type 5 route. All right, so let's see if the border leaf in the VRF prod can ping the server. And it does not appear that we can. So based on the route output, it appears that leaf 6 is advertising the route here for the file server. And that's indicated by VTEP 6.6.6.6, which is the loopback on leaf 6. Okay. So let's jump over to leaf 6 and take a look at the route. So here it points to a BGP peer attached to ET3. Let's see here. Based on the interface description, this is a vendor partner link. I'm not sure if this is facing the file server. Can leaf 6 ping the file server? Appears that we cannot. So after speaking with the network folks over at the vendor partner, they've indicated that the 11.11.11.111 file server is not located within their network, and they reached this via an eBGP route from their ISP. However, if we take a look at the received routes, sorry, we need to add the VRF prod here. We can confirm that we are receiving the 11.11.11.0/25 prefix from the vendor partner here. So, since the customer's expectation is that the file server should be reachable via the border leaf, let's go back to the border leaf and investigate a little further. If we take a look at show IP BGP, show IP BGP 11.11.11.0 VRF prod, we can see that there's only one path here. And again, that is via leaf 6. Let's take a look at the entire B-rib here. And we can see that we indeed have two entries for the 11.11.11.0 prefix. So the one from our ISP has a /24 mask, whereas the one from our vendor partner through leaf 6 has a /25 mask. You know what they always say, longest prefix wins here. Okay, since our vendor partner indicated that they don't own the file server, perhaps we should see about fixing that route that we're learning from the vendor. So let's go back to leaf 6 and let's take care of the erroneous 11.11.11.0/25 prefix. So to do so, first we'll create a prefix list that denies this prefix. So here we have a prefix list that denies the 11.11.11.0/25. And then we have another entry that permits everything else. This is because there's an implicit deny in the prefix list. So next, we'll need to create a route map. So here we have a route map that matches the prefix list we just created. Then lastly, we'll add this prefix list, this route map rather, inbound on the neighbor. So under router BGP and the prod VRF, we've applied this filter inbound route map inbound from the peer. Now let's see. So now we can see that we have a /24 in BGP, and the next hop is indeed the border leaf. So let's check the route on the border leaf now. And indeed, we're learning it from our ISP. So can the border leaf ping now? And we can. What about our hosts? And they're all successful. So the issue here is that we have a vendor partner BGP peering, and the vendor partner was erroneously advertising the 11.11.11.0/25 prefix to us via the VRF prod. And that's injected into EVPN, and it was overtaking the border leaf's 11.11.11.0/24 route because it was a longer prefix with a /25. So we put filtering in place on the vendor partner peering inbound to filter out the 11.11.11.0/25. Okay, so let's look at the summary for problem statement 2. Various hosts could not reach the 11.11.11.111 file server. The Leaf 1 received a Type 5 IP prefix for 11.11.11.0/25 from Leaf 6. Leaf 1 forwarded traffic towards Leaf 6. Leaf 6 had received a route for the 11.11.11.0/25 from its vendor partner BGP peering. Leaf 6 forwarded traffic onto towards the vendor partner, but no return traffic was observed. The customer expectation was that this subnet should be reachable via the border leaf. We've referenced some of the commands here for your reference. We've also included in the slides the TOIs for the various technologies that we discussed here today. And thank you for attending. And with that, we'll take any further.
Awesome. Thank you, Rich. Can you go on to the next slide, please? Perfect. So thank you so much, Rich, for the deep dive and for covering this topic in detail. Really great technical stuff here. And we do sincerely hope that this session was useful for all the customers who joined us today. Again, recording for this session along with all other previous sessions are available, and this session will be uploaded shortly on the Arista community page, along with the presentation reference material and the questions what we have covered as part of this webinar. I actually would like to highlight that along with these materials, there are a number of good articles that are also available on various other topics on the Arista community that can be helpful. So definitely recommend everyone to leverage that knowledge base. Also, for our customers who would like to test these network topologies in a virtual environment, we do have Arista Virtual EOS on our software download portal available that can be utilized on your local machines, or we do have Arista Cloud Test environment. If you're looking for more details on the ACT environment, which is a paid offering, please reach out to TAC-Webinar at arista.com. Again, today's session concludes our 2023 series. Our 2024 series is scheduled at this point, and first session is scheduled for 31st of January at 11 a.m. Eastern. So we highly recommend everyone to attend that. Also, taking a cue from the technical deep dive that we just went through, if you're interested in scoping a custom training session with us, or just interested in learning more about the Arista TAC custom trainings, please reach out to us on tac-custom-training@arista.com. Our panelists have put in a short feedback form link with 3 to 4 questions in the chat. So we really encourage everyone to provide your valued feedback. Take some time, please provide your valued feedback through that Google form, and we definitely intend to use it for our future sessions. So I'm going to keep the webinar open now to wrap up on the Q&As and answer any questions that you may have. You can use the Q&A manager to ask our panelists any questions at this point. There's a question from Ron about the multicast. We definitely are thinking about this, Ron. Definitely, that's one popular topic for which we have received a lot of requests. So in 2024, definitely we are not sure at this point. We'll be including it in Q1, but you definitely see this as part of our 2024 webinar series. And also, if you have any other topics in mind that you would like to see included in our webinar series, request everyone to provide that feedback through our Google form link, what we have just put in. Thank you, Bruce, for that awesome feedback. Really appreciate it. Thank you, John. Okay, if there are no other open questions, I would end the webinar at this point. Thank you, everyone, for joining us today again, and enjoy your holidays, and looking forward to seeing you again in 2024. Thank you so much.